Hello everybody, in this video I want Arduino board to talk to me. So that is voice broadcast. Voice in Chinese is 语音 broadcast 播报. So voice broadcast is 语音播报. Since 1978, the TI company they development a kind of speech chip use the LPC, linear predictive coding system. And 40 years passed, and today we have another Talkie library for Arduino. This is a kind of software implementation. So if we want to use that library, of course, first in Library Manager, search Talkie, and then install Talkie library. How to connect? This one we just need to connect a speaker. I use Arduino Uno, so I can connect normal pins to pin 3. Today's sketch is based on previous DHT11 sensor sketch. Do you remember that? We use the Arduino board to connect DHT11 temperature and humidity sensor, and also use one LCD to display temperature. I want Arduino broadcast the temperature, so in this sketch, I need to include some Talkie head file. Let's go inside the Talkie libraries folder and find what's interesting inside. We will use vocab US large. There is a CPP file, C++ file. Open that. Look at this, SP20. There are some hex coder, and SP21, SP22. Now you can understand. In fact, every section folder, in fact, is English word. This English word already stored in LPC format. So this code is LPC format. Now I want to temperature. Let's search. Also, we can find this word is here. So this code is temperature pronunciation code. After checking the coding, let's create the sketch. Here I define a button number 2, because after I press button, I want to Arduino talk to me. Then I create a Talkie's instance voice. The other part is about LCD and DHT11 in previous video we already introduced. So let's see this part. Now if I press the button and voice CQ function will first speech which word? Temperature. After that, CQ float, because here is a T. T means temperature. We will use our voice to pronounce temperature. Then after that, we will use the CQ to pronounce degree, this word.
Temperature 21.1 degrees. Temperature 21.1 degrees.
Simulation, we just need to add a sounder. So in pick device dialog, input sounder. And this one, we can use this. So just connect one pin to IO3. Sounders another pin. You can connect to ground or connect to IO11. You heard a lot of noisy because this LPC format is almost 40 years ago. That time, the frequency output only 8 kHz. However, today's simulation, let's see this sounder. Double click. You will see playback sample rate from 11 kilo to 44 kilo, no 8 kilo. So that's why they are not matched and noisy happened. Talkie library by default only can talk English. So I'm thinking, can we let it talk Amharic? The answer is yes, and it's also interesting. So I list the instruction and some tools we need. Next, I will introduce that step by step. We need to record the voice first. We have two choices. You can select Golden Wave, this software. You need to pay money, but if just simple use, you can use the demonstration version, or you can use Audacity. This is a free software. In Golden Wave, we need to create a new recording file. Click New. And the number of channels, select 1, mono. Sampling rate is 8000, and click OK. Pay attention, our Arduino talking library only supports Wave PCM signed 16-bit 8000 Hz. So, if not this format, is not supported. Now let's record the Amharic word. For example, I record hulat, sourced. Then you can select a part of recording. For example, here is hulat, this part. Hulat. Then as file, save selection as on the desktop. Hulat. Format is WAV. Default is WAV. Save that. LPC voice format is too old, not support today's operation system, so we need some old-fashioned. We use Windows 3.1. This web page we can find the linkage of Windows 3.1. But how to run in Windows 3.1? Another tool is DOSBox, and for LPC encoding format tools, we use another QBox Pro. Linkage is here. I already downloaded the QBox. Open QBox folder. You will find there are qboxpro.ini. Open that, and search a parameter is LPCNB. Search that. Default value is 12, but not work for us. We need to change it as 10, and save that. Open Win31 folder and Windows. Copy this QBox Pro INI to this Windows folder. On the Windows 31, we directly copy QBox folder to here. On the Windows 31, also create a new folder. For example, name is Wave, WAV. We need to copy our recorded sound file to this Wave folder. After finish preparation, open DOSBox and use mount space C space and the directory is our Windows 31 folder. So C users, my name Jiang, desktop, and Win31 folder. We go to virtual disk C and use WN Win start Windows 31. Now use file, run. Select this on the folder C, QBox Pro. Click OK. If there show you some warning, forget that. Okay, then I create a new SPF. For example, I create this SPF file under my Wave folder. Select Wave. Give a name because this is Hulat, so I call Hulat SPF. Click OK. Sampling frequency is 8 kilo, and the coding table we select 5220. Okay, and project add file. Select hulat.wave. Process, select medium bit rate. Leave its default. Click OK. Okay, after that, edit concatenations. Insert concatenation. Name is Hulat. Click OK. And then insert face. Leave default. Click OK. Format. Select LPC 10V 4UV. Click OK. Then select Save Project. After that, we open Win31 and the Wave folder. You will find there generate a lot of files. The most important is hulat.bin file. Then to this web page, download bin2h program. After download bin2h, open that folder and copy our hulat.bin file to this folder. bin2h is a command line program, so we need to open command window and go to this folder. Use bin2h space hulat.bin, convert to hulat.h, enter. Then generate hulat.h. You see, this hex file is Amharic language. Open our Talkie library folder and open vocab us large.cpp file. We need to change English to research to sp2 underscore 2. This is English 2, and if we copy our Hulat code, change this 2 code. Now English already converted to our Amharic. Use this method, change as many words as you need. For example, 0, 1, 2, all of this already changed as Amharic. Then